So today we're going to be going over 4.2 day 2. This one is going to be talking about reflecting the graphs across the x-axis and then doing vertical translations. Our first one is going to be the graph of y equals -2 cosine of x from -2 pi to 4 pi. So the first thing we're going to do is we're going to draw our x and y axis. From -2 pi all the way up to 4 pi. If we started with our parent function of our cosine graph, that would start at 0. Go down, or start at 1, sorry. Go down to 0, down to -1, back up to 0. So our parent function never changes. That's always going to be the same for our cosine function. So that is what our parent graph would look like. And then the number in front, you'll notice, is a little bit different than normal, because normally we have been working with positive numbers, and this time it is a negative number. Our amplitude is still going to be 2 for this problem. And our period is still going to be 2 pi over 1, because our b value here is 1. So our period is still 2 pi. That's where we'll make one full cycle. But now we have this negative, so it's going to flip our graph over. So if we take our first point, which is at 1, if we multiply that by -2, we're going to get -2. So we're going to move our point down here. 0 is still going to stay at 0. -1 times -2 is going to become a +2. So we're just going to take all of these values and we're going to multiply it by -2 to get our new graph after our reflection. So it's very similar to changing the amplitude. We're just also flipping it over the x-axis to get this new graph. If we continue that over on the other side, there we go. And this is how you would graph the function y equals -2 cosine of x. Okay. So that's what's going to happen to our graphs when we reflect it over the x-axis. The next thing we're going to do is vertical translations. And vertical translations occur when we're adding or subtracting something outside of the cosine value, and we're not multiplying it by it, but we're adding it outside. So this is going to move our graph up or down. So if we look at this, we're going to graph y equals -2 cosine x plus 1. You'll notice this is the same graph that we just did up on the top. So if we just recopy that down, the only thing different is we are going to be moving it up 1 because of this +1 over here. So that means we're going to move it up. So if we continue to go ahead and graph this, we're just going to copy that down. Sorry about the dogs in the background. Okay. So because we already have it drawn on the top, we don't need to redo it again. We're just going to be moving it up 1 space though. So our first point was originally at -2. Now it is at going to move up 1, so it's going to move to -1. And then our second point was at 0, so now that one's going to move up to a 1. So this point will be at 1. Our value at pi was at 2, so now that one's going to move up to 3. So we're just going to keep going through and moving all of these up by 1. And if we look at this graph, once we get it drawn, we're not going to be changing the value of the amplitude or the period. That is still going to be the same. The only thing we did is we shifted it up 1 value. You'll notice the amplitude goes from the center of the graph, and our center of the graph is going through this line here. So our amplitude for this is still going to be 2, just like it was on the last graph. And if we finish, this is what the rest of the graph would look like. So the only thing that changed is we moved it up 1. Our next example is doing the same thing, except this time it is moving it down 2 because we have a -2. So if we go back to, again, our original graph from example 1, we're just shifting all of those points down 2. And I'm just going to change this because we don't need to do all of this, and we'll just go from 0 to 4 pi for this. So if we just draw our sketch really quick, we're going to 4 pi, middle would be 2 pi, pi, and 3 pi. So back to our original graph. On this one, we were down at -2. Now we need to move that down 2 more. So we're going to go down all the way to -4. And that's going to be our point on the y-axis. Our next one was at 0, so that one's going to go down 2 again. So that would be at this point right here. At pi, we were at +2, so now we're going to move that one down to 0. And we just continue on with the rest of our graph, moving all of the points down 2 spaces. And again, if we look at this, we're not changing our amplitude or our period for this. We are just changing the location of the graph on the coordinate grid, but we're not changing any of the amplitude or period. Our amplitude for this is still going to be equal to 2 because it goes from the center line. And then our period is still going to be 2 pi. And you can see that from this 0 point to this one, that changes 2 pi. So nothing else changed. We just moved it up or down. All right. The next thing, we are going to practice doing y equals the cosecant of 2x from 0 to 2 pi. So for this one, we can still find our period the same way that we found our period of our sine function. So our period, if you remember from yesterday, is 2 pi over our b value, and b is the value that goes in front of x. So this one, our period, is equal to 2 pi over 2, which simplifies to pi. And our amplitude for this is the number in front, our a value, and this one doesn't have one, so our amplitude for the parent function or the sine function is going to be 1, but the cosecant function doesn't have an amplitude of its own. So this would be the amplitude of our sine function. Then we'll go ahead and we'll draw our x and our y axis. We're going all the way up to 2 pi. And one full period of our sine function needs to be within pi because that is what our period got changed to. So we need to add 5 points from 0 to 2 pi, or to pi. And we go up to 1 and -1. All right, and sine always starts at 0 unless we are adding or subtracting something to it. So we start with our sine function here. And remember, this isn't the final graph. This is just what we're going to use to find our asymptotes and then also our maximum and minimum points. Our asymptotes are wherever the sine function equaled 0 because that is where cosecant would be undefined. So at all of these points where sine equaled 0, we are going to put our asymptotes. Remember, when we draw our cosecant function, we don't want it to cross these lines because that is the purpose of the asymptotes. And then we can draw our arches of our cosecant. And there we are. So that would be the graph of the cosecant from 0 to 2 pi. All right, our next example, we have y equals 3 times the cosecant of 2x from 0 to 2 pi. So looking at our last graph, this one is kind of going to be our parent function because it's the cosecant of 2x. Our next one is the same thing except we're multiplying it by 3. So that means our sine function would then have an amplitude of 3 instead of an amplitude of 1. So the only thing that we need to do is we need to multiply everything by 3, all of our y values by 3. Our asymptotes are still going to be in the same place because we are not moving our graph any direction. So that's going to be at every pi over 2, we have an asymptote. And we are just getting this from our last graph, so we don't need to draw another parent function because we already have it there. So if we look at this starting point was at 1. If we take 1 times 3, our new graph is going to be up at 3 and start opening up. That is the only thing that's going to change. And then our next part of the graph started at -1. So now instead of starting at -1, it's going to start at -3. Everything else on here stayed the same. So once we have these drawn, we are all good. So always start with your parent function if you have that, and then you can use that to do the multiplication of 3 in the front. But this is the same thing. You'll notice the periods are the same. The only thing that changed was where the maximum and the minimum points were. So for this, if b is a positive number for secant or cosecant, you can still find the period the same way we found it for our sine and cosine functions, which is just 2 pi over b. And then for tangent, we can find our period by pi over b. That one's a little bit different. If you remember when we graphed those, that had a period of pi for the original function. So to find the new period, we would just take pi over b, and that works for both tangent and cotangent. So for this, we are going to graph y equals 3 times the tangent of x from -pi/2 to pi over 2. So the very first thing I'm going to do is I'm going to draw my x and my y axis from -pi/2 to +pi/2. And we're going to need some more points in here. In the middle, or half of pi over 2 would be pi over 4. Okay. And remember, we can use our unit circle to help us find those coordinate points on the graph. So this one would be at 1, 0, 0, 1. All of these points can help us find the critical values on our graph function. Remember, the coordinate points are cosine, sine, and tangent is equal to sine over cosine. So if we start at the beginning, if we do the sine of 0, or sorry, the tangent of 0, that would be 0 over 1, which is just 0. And then if we do the tangent of pi over 4, that would be in the middle, so that one's not on here. But if you remember, the tangent of pi over 4 is going to equal 1. And that's because you would get the 45-45 triangle. So the tangent of pi over 4 is going to equal 1. And if we did the tangent of negative pi over 4, that would be negative 1. And then if we did the tangent of pi over 2, that would be 1 over 0, so that's undefined. So that means we're going to have an asymptote at the pi over 2. And the same thing happens when we go to negative pi over 2. We would have negative 1 over 0. So this one is also an asymptote here. Oh, I put that 1 point. It was negative pi over 4. That's where it's going to be negative 1. So this is our parent function for our graph. The next thing we need to do is we need to multiply it by 3 to get our real function that we're looking for. So we need to just multiply all of our x values by 3. Our first one in the middle, 0 times 3 is 0. And then we are going to go to the right, and we have 1 times 3, which is going to equal 3. And then if we go to the left, negative 1 times 3 is going to equal negative 3. So we are going to plot that point down here. And now we have enough information to connect these 3 points and graph our function. So for a tangent and cotangent function, for each period, you should have at least 3 points. 1 in the middle and 1 on each side, just so you get the shape of the graph. All right, I hope these notes help you on the homework. If you have any more questions, please let me know, and have a great day.